All right, so welcome to the Math 123 Exam 3 review. We're going to be doing questions today over Units 1, 2, and 3 since your exam is cumulative. And you will want a few things in front of you before you start watching this video. You will want your formula sheet for the exam, and you will also want a calculator and then probably a pencil and something to write on so that you can take some notes and do some of the work. So let's go ahead and jump right into the questions here. So this first question says that Amy is on holiday in Florida where it is a whopping 107 degrees Fahrenheit. She wants to tell her friends in the United Kingdom how hot it is in degrees Celsius so that they will understand her misery. What should she tell them? So what I would recommend doing throughout this video is once we've sort of read through the question, go ahead and pause it for a minute, try the question, and then we'll go ahead and go through the solution. So in terms of the solution for this one, let me go ahead and create a text box here. If we take a look at the two formulas that I have pasted, these are on your formula sheet, all right? But since we have Fahrenheit and we are looking for Celsius, I'm going to be using the formula that is C equals because I am trying to find Celsius. So I have 5 over 9 times, and then I have a parenthesis, and then I have my Fahrenheit temperature, which is 107 minus the 32 that I'm given. So this is what I would actually plug into my calculator. All right, so you want to go ahead and take a second, go ahead and do that. And let's see what we get here for our answer. I am getting something like Celsius would be equal to 41.67 degrees Celsius, something like this. All right, so that would be my answer for this first one. Now, depending on how many decimal places you're asked to keep, you might have a slightly different answer, but something like this is what you should get there. All right, let's go ahead and go on to the next question. So this is sort of a multi-part question. This is a metric question. So it tells us that there are 1,430 decameters, and we want to know how many kilometers that would be, meters, and then centimeters. So the way that you want to think about this is you kind of want to figure out where you're starting, which in our case is going to be at decameters, which is going to be kind of down right here, okay? And you want to sort of see where you're going. So to go from decameters to kilometers, if I take a look, I'm starting at decameters, which is right here, and I'm going to be moving to the left 2 spots. So all I actually need to do for my answer is move my decimal 2 spots, and it's going to be to the left. So if you think about it, it's starting just at 1430, and then I pick up my decimal place and move it over, it's going to be 14.30 kilometers. So that would be my answer for this first one. Now, to go from 1430 decameters into meters, if I take a look, again, decameters is down here. Meters is just my base unit, so that's going to be 1 to the right. So all I'm going to do with my original question is take my 1430, and I'm going to move my decimal place 1 to the right. So if you recall, you can kind of think about it as like a bunch of sort of trailing zeros there. And now if I take my decimal place and I pick it up and I move it 1 to the right, I end up with 14,300, and that's going to be meters. So let me go ahead and put my label there. So that would be this one. And then finally centimeters. So I'm going to start with my 1430 decameters, which is right down here again. And I want to go to centimeters. So if I count my spots that I have to move, I have to go 1, 2, 3 spots to the right. So that tells me that I'm going to have to tack on 1, 2, 3 zeros. So I'm going to go ahead and put my commas in so I can make sure that it's sort of legible, and then I'll just put cm for centimeters. So those would be my answers there. And one sort of way to double check this would be to work your way backwards. So for example, if I start at 14,300 meters, that would be right here. If I want to get that into decameters, I'm going to move 1 spot to the left, and that would give me the 1430 that I had. If I start with 14.3 kilometers and I want decameters, I'm going to move 2 spots to the right, and that would give me the 1430. And then centimeters, if I start with 1.43 million centimeters, I'm going to move 1, 2, 3 spots to the left, and that gets me back to the 1430 decameters that I had. Okay, this one is a CO2 question. So it says Cassie is planning a summer road trip where she will drive a total of 700 miles. She drives a Prius that averages 45 miles per gallon, and we know that gasoline produces 19.8 pounds of carbon dioxide for every 1 gallon of gasoline. And that 19.8 pounds of CO2 for every 1 gallon of gas, that is actually from your formula sheet. So what we're going to do for this particular problem is set up sort of like one of those dimensional analysis type questions where we have numerators and denominators. And it's going to be a little bit difficult for me to kind of type out, but I'll do my best. And if you're using a piece of paper, it'll look a lot nicer, okay? But we're going to start with the distance of the trip, which is just going to be the 700 miles, and that's going to be divided by 1. So that would be your very first fraction that you're going to have. And the next thing you're going to do is you're going to use the gasoline consumption, or basically like the efficiency, which is the 45 miles per gallon. So if you have this set up again on a piece of paper, it's going to be easier to see, but we're going to have something like 1 gallon over 45 miles because, let me go ahead and scoot this over so we can see it still, because we have miles in the numerator of our first fraction, which tells me that I should have miles in the denominator of my second fraction. And then finally, the last thing I'm going to do is use the 19.8 pounds of CO2 for every 1 gallon of gasoline. So again, if you have this set up on a piece of paper, it's going to look a little bit nicer, but you should have the 700 miles over 1, the 1 gallon over 45 miles, and then the 19.8 pounds for every 1 gallon of gasoline. So you'll go ahead and put this in your calculator. Let me go ahead and do this. And I believe we get exactly 308. Let me go ahead and put my answer up here. 308 pounds of carbon dioxide. Let me move it down here so we can see. So something like that for this one. Okay, one more CO2 one with a different sort of setup. This one says we have a 150 watt light bulb and it is on for 12 hours a day for an entire week. And we do know that 1 kilowatt hour produces 1.37 pounds of CO2, and we want to know how many pounds of CO2 are going to be produced by this light bulb. So in this particular situation, what I would probably recommend doing is going ahead and doing a little bit of side work in order to figure out the total number of hours that it is in use. So if you think about it, if it's in use for 12 hours a day, and you're doing that for an entire week, if you take 12 times 7, you're going to get a total of 84 hours. So that's going to help us set up our problem. So we're going to start with our 150 watt light bulb divided by 1. And then hopefully you recall, we always need to go ahead and change watts into kilowatts. And if we set this up, we're going to have 1 kilowatt divided by 1,000 watts. And again, this is one of those ones where if you set it up on your paper, you're going to be able to see the units canceling a little easier than I have it up here. But if you think about it, watts are going to be in the numerator of the first fraction, so they should be in the denominator of the second. And then I'm going to use my hours that I have, which was the 84 hours. So again, we got that just by taking 12 times 7. And again, I would just go ahead and do that kind of on the side to figure it out. So it's 84 hours. And then the last piece we're going to have is the 1.37 pounds for every 1 kilowatt hour. So this kind of moved onto a separate paper. So let me abbreviate the 1,000 watts so it all fits on one line. So we have our 150 watts over 1 kilowatt over 1,000 watts, 84 total hours, and then 1.37 pounds of CO2 for every 1 kilowatt hour. So if you go ahead and you set this up in your calculator, let's see, I am getting an answer of 17.262. And let me put it right down here. So we have 17.262 pounds of CO2 produced. So this is always going to be the setup that you're going to have if you're given some kind of wattage. Basically, you change watts into kilowatts, multiply by the number of hours, and then use the fact that 1.37 pounds of CO2 are created for every 1 kilowatt hour. Okay, this says Brenda and her colleagues are feeling mischievous while their boss is out of town, and they want to cover the office floor with bubble wrap. So they tell us that the office measures 8 by 10, both in feet, and we want to calculate how many square yards of bubble wrap they would actually need to purchase in order to cover the floor. So there are actually kind of two formulas that we need to know here. The first is that area is length times width, and that I believe is on your formula sheet kind of all the way at the bottom of the front page. And we're talking about area because we're just covering something, we're not actually filling it up. So we're going to take the 8 feet and multiply it by the 10 feet. And if we do that, we should get 80 feet. And then I'm using a caret to denote that it's squared. Okay, so I have 80 feet squared. Now, the thing that we need to keep in mind is that if we were purchasing bubble wrap that were already in square feet, then we would be done with our problem. But that's not exactly what's happening here because it's asking us to calculate the number of square yards that would need to be purchased. So in this case, what we need to do is we need to take our 80 feet squared and we need to put it over 1, and we're basically setting ourselves up with like another dimensional analysis problem where we have all of our little fractions multiplied by one another. So this one, since we have feet in the numerator of the first problem, that tells me I'm going to have feet in the denominator. And I do have a conversion directly from yards into feet, and that is that 1 yard is the same thing as 3 feet. Now, this is about halfway there because if you think about it, we have feet squared as our unit. I have only gotten rid of one of the feet. So what I need to do is I need to use this fraction once more, the exact identical same fraction there, and that is going to give me my actual value. And I believe if you do this in your calculator, you will get something like 8.8 repeating. Okay, so we'll do 8.89 square yards, something like that for your answer. Or if you wanted to round to the nearest whole number, they would need 9 square yards in order to cover their office. Okay, let's take a look at this example. So this says the number of hours spent studying for an exam were collected from 5 students, and the results were as follows. So one student studied for 5 hours, another student studied for 1 hour, one student didn't study at all, and then we had 2 students who studied quite a lot for 15 and 10 hours. And it asks us to find the mean and then the median. And these should be things that you guys are familiar with. I know it's been a while since we did it. But the mean should be found by adding everything and then divide by number of values. And then the median, if you guys remember, is the middle number. All right, so let me move these a little bit. But those are kind of like the formulas, I guess, that we're using here. So the mean, I'm just going to add everything up. So I'm going to take the 5 plus the 1 plus 0 plus 15 plus 10, and I get a value, so for my mean, I'm getting 31, but I need to divide that by the number of numbers, and I have 5 total values that are given. So the mean is 6.2, and this is going to be hours. So that means that the average time spent studying is 6.2 hours. Now, median, I set up here, is the middle number, and one thing that you need to actually keep in mind here is that it's the middle number if the numbers are put in order. So the way that you want to think about this is you probably want to reorder your numbers. So you're going to have a 0, and then a 1, and then a 5, and then a 10, and then a 15. So I haven't lost any of my numbers here, but I did go ahead and kind of space them out so we can see them a little better. Oops. And let me add a few spaces here as well. So now if we take a look at the way we have this set up, now I can go ahead and find the middle number. And essentially if you cross off the lowest number, highest number, lowest number, highest number, you end up with a 5 in the middle, so that would be your median. Now keep in mind, oops, lost my text box here. So the median is going to equal 5 hours. But keep in mind that if you have more than one number in the middle, then you are going to add them and divide by 2 in order to find the median. Okay, this one says using the fact that an A is worth 4 points, a B is worth 3 points, and so on, calculate the student's GPA. So what we're going to do for this one is I'm going to go ahead and next to each of their letter grades, I'm going to put the point value that goes with it. So I know a B is worth 3 points. A C would be worth 2 points, and a D would be worth 1 point. So I'm going to put a 1 next to that D grade. And then an A is worth 4. So Let me put that there. So here are their actual point values. Now, GPAs, if you guys remember, are weighted average questions. So all we really have to do is we have to multiply and add and then divide by the total of the weights. So what we're going to do over here is we're just going to multiply straight across. So I'm going to do 3 times 3, and I get 9. And then I'm going to do 4 times 1, and I get 4. And I'm going to do 4 times 1 again, and I get another 4. Let me scoot this down so these are like next to the correct values, but should look something like that. So I have a 3 times 3, since a B is worth 3 points, 4 times 1, since a D is worth 1 point, and 1 times 4, since an A is worth 1 point. And then all we have to do is we have to add those things together. So I take the 9 plus the 4 plus the 4, and what this tells me, so if I do 9 plus 4, I end up with 17. So that tells me that they earned 17 total points. And then we have to divide, in this case, by the number of credit hours, because our credit hours are our weights. And if you take a look at the number of credits that they're taking, they actually have 8 credits because they have a 3 credit hour class, a 4 credit hour class, and a 1 credit hour class. So if we put those together, that ends up being 8. And if we divide those two things, I think we get a GPA of 2.125. So that would be our answer for this one. So again, it's multiply, add, and then divide by the total number of the weight. Okay, here is a similar example, but this one asks us to use the following information to calculate the student's grade in the course. And this is a weighted average where everything is a percent. So we know that homework is worth 25%, and quizzes are worth 30, and exams are worth 45, and then they have different grades on each of these. So what we're going to do is same original process. So we're going to take our weight and multiply by our grade. Now the thing that we will want to do is we will want to change our weights into decimals and then leave our grades as whole numbers. So for example, for that first one, I'll go ahead and put it down kind of here. I'm going to do 0.25 times 87. And then for the next one, I'm going to do 0.30 times 72. And then for the next one, I'm going to do 0.45 times 64. And then I'm just going to put what these actually all end up being. So let's see, 0.25 times 87, that's 21.75. 0.3 times 72 is 21.6. And then 0.45 times 64 is 28.8. And there are a few ways of thinking about this, but to just kind of explain what these values mean, I did the homework first. So homework is worth basically, like, you could think about it as 25 points. And the way that you can look at this particular student's setup is that they have earned 21.75 out of the 25 possible points. For quizzes, they've earned 21.6 out of the 30 possible. And for exams, they've earned 28.8 out of the 45 possible. So in order to get their grade, actually all we have to do is add those numbers up that we just got. So we take the 21.75 plus the 21.6 plus the 28.8, and I end up with a grade of 72.15. So add everything, and I'll move this over in just a second, and we get a 72.15 in the class. And if you take a look at their grades, they did really well on their homework. They have a high B, but their quizzes and exams, which are worth more of their grade, those are a little lower. So it does kind of make sense that they are in sort of that low C range. The homework brought it up a little bit, the exams brought it down quite a bit. Okay, this one says the number of Oreos eaten in 1 year by a person is normally distributed with a mean of 42 and a standard deviation of 7. What percentage of people eat between 35 and 49 cookies per year? So there's actually a rule that we have to remember in order to solve this problem, and that's the 68, 95, 99.7 rule. And if it's been a little while since you've looked at this and it's a little bit fuzzy, just go back and take a look at some of the lecture notes that you have from that. But the basic idea is that 68% of observations are within 1 standard deviation from the mean, and 95% are within 2 standard deviations, and 99.7% are within 3 standard deviations. So all we need to do is we need to figure out 35 to 49, how many standard deviations away is that? So if you think about it, we have 42 kind of smack dab in the middle, all right? And this, the program I'm using is not great for drawing pictures, but let me move this up a little bit, move this down. So if you think about it, I'm gonna have 42 kind of right in the middle, and then if I add and subtract standard deviations, to the right, I would get a 49 if I add 7, and then I'd get 56 if I add 7 more. And then if I add 7 one more time, I get 63. So those would be the values that I would have in that direction. And then over on the left, if I take 42 and I subtract 7, I get a value of 35. So let me put a 35 over here. Same idea. 35 minus 7, that gives me a value of 28. And then finally I get a value of 21. So basically what I'm doing is I'm just putting 42 in the middle and going kind of in both directions to see what's happening. And I would probably draw this like under a curve if I were drawing an actual picture. But the basic idea is that I want between 35 and 49 cookies. And if you take a look at this, they are both just exactly one standard deviation away. And that just goes with my rule that I have. So my rule tells me right away that I have 68% of my observations because I am only one standard deviation away. So my answer would just be 68 for that one. All right, let's take a look at this question here. So this says the number of Oreos eaten in 1 year by a person is normally distributed with a mean of 42 and a standard deviation of 7. What is the z-score for a person who eats only 36 Oreos per year? So I did paste the z-score formula down here. Okay, that is on your formula sheet. But the basic idea is we are going to take our data value, which is going to be the thing that we're interested in. So in this case, it's the 36. And then we're going to subtract the mean, which is 42. And then we are going to divide by the standard deviation, which is 7. Now you'll notice here that I put parentheses around the numerator. And the reason for that is because if you are doing this in your calculator all at once, you have to put parentheses there. If you're going to do it in steps, you can do 36 minus 42 and then hit equals and then divide it by 7. Either way is completely okay. This one is actually going to be a negative z-score, and the reason for that is because we have a person who is eating a smaller number of Oreos than the average person. So if you have things that are below the mean, you're going to have a negative z-score. If you have things that are above the mean, then you should have a positive z-score. So in this case, if you actually subtract and divide, I think you get something like, if we round to the nearest hundredth, negative 0.86, because it's like negative 0.857. So that should be our z-score. So what that tells me is that a person who eats only 36 Oreos per year is 8.6 standard deviations below the mean. Or not 8.6, 0.86. Sorry about that. Okay, let's take a look at this one. So this says Honduras has one of the highest murder rates per capita. There were 7,172 murders in Honduras in 2012 out of 7.936 million people. And we're asked to calculate the murder rate per capita. So if you guys remember per capita questions, basically we take whatever it is we're interested in, which would be the number of murders, and we divide it by the population. So in this case, we have to remember a couple of things because I have to remember how to write this out, okay? But 7.936, that is going to look something like this for millions, all right? So I have almost 8 million there. And if we go ahead and divide this, let's see, 7172 divided by 7936. Don't forget the 3 extra zeros on there. Get a pretty tiny little number, 0.000904 if we round. So this is our murder rate per capita. So that means that for every one person, there are 0.0009 murders. All right, so that's what that's going to tell you. Okay. Let's take a look at this example here. Oh, one other thing I want to point out here. We could be asked to write this in scientific notation. So let's go ahead and review that real quick. So in this case, I would make this into 9.04. and then it's going to be times 10 raised to some power. Now, since this is what I would call a tiny number, we are going to have a negative exponent. And in this case, if I count the spots that I move, it would be 1, 2, 3, 4. So it would be 10 to the negative fourth power. So the two answers here are equivalent, but they're in different forms. So make sure you pay attention to whether you're asked for standard notation, which would be this first form, or scientific notation, which would be the times 10 to some power. Okay, so using CPI values from above, solve the following problem. Dennis purchased a boat in 2014 for $14,000. What would have been the equivalent price if he had purchased the boat in 2010? So if you guys remember how we typically set these problems up, I normally like to put, it doesn't like that, dollars up on the top, okay, and then I like to put my CPI values kind of down below, so I'm going to do something like that. And we are just going to set up two sort of proportions that are just equal to one another, all right, so I'm going to have something like this. And in those proportions, I am just going to kind of fill in the values that I have. So the first dollar amount that I have is $14,000. So I'm just going to put that on the left over here. And then the other dollar amount is one that I don't know, what I'm trying to figure out. So that's going to be my X, right? And I'm just going to put that over there. Now, the only other thing that you need to be careful with, and let me see if I can make a line here. Should be able to make a line. Okay. That's not quite what I wanted. That is a box. Huh. Whoa. Did not really want a red fraction, but that would be okay. Let's see. See if I can move this and make it a little smaller. Nope, I'm having some issues with that, so we're going to go ahead and undo the creation of that, and we'll just pretend like there are fraction bars here. All right, so there should be fraction bars under the 14,000 and the X. Okay, there aren't, but we can just pretend for a minute. And then all we need to do is we need to put the appropriate CPI values there. So the 14,000, it tells us that it goes with the year 2014. So what that tells me is that I should grab the 2014 CPI value and use that over, or right below my 14,000. So my 2014 CPI value right from my table up here is 236.15. So I'm going to put that right below my 14,000. And then I just have to grab the other table value, which is going to be from 2010, and that would be 218.056. So again, I'm missing my fraction bars here, but if you go ahead and cross multiply and then divide, let's see what we get here. All right, I am getting a value of 12,000. Let's see, let me go ahead and get a text box here. $12,927.31 is what I have. And if you look at this, it does kind of make sense, okay, because the basic idea is that over time, prices of things should increase. So if we have something that someone purchased for $14,000 in 2014, it should have been cheaper in 2010. So this does kind of follow sort of our intuition for this particular question. Okay, this one says 41% of Americans age 18 and up have a favorable view of Hillary Clinton. This was based on a survey of 1,200 adults. We want to construct and interpret the 95% confidence interval using the margin of error. So I did put the formula down here for margin of error. It is plus or minus 1 over the square root of n. So when we go to actually calculate this, so margin of error, I'm just going to abbreviate that. I'm going to have plus minus 1 divided by, and then I'm just going to use square root, SQRT, to abbreviate that. And if you guys remember, n is actually the sample size. So in this case, it's going to be 1,200. So all you're going to do in your calculator is take 1 divided by the square root of 1,200, and you should get a value like 2.89. All right, so 2.89, or 0.0289, which we would then change to a percent of 2.89%. So you want to keep in mind that with margin of error, in order to use it to actually interpret, we go ahead and change it to a percentage. So now, in order to construct the confidence interval, all we have to do is take the percent that we're given and then add and subtract the value that we just calculated. So I am just going to take the 41% and then add and also subtract the 2.89%. So if you do 41 minus 2.89, you'll get 38.11%. And then if you take 41 plus 2.89, you'll get 43.89%. So that's going to be your confidence interval. And then in terms of an interpretation of some kind, there are a lot of ways you could state this, but we can say something like, we are 95% confident that the true proportion of Americans age 18 and up who have a favorable view of Hillary Clinton is between 38.11% and 43.89%. So it's going to look something like that, all right? So again, we had to calculate the margin of error by taking 1 over the square root of n. We add and subtract it from the sample percent that we're given, and then we go ahead and we interpret it. Okay, let's take a look at this question here. So this is a probability question. So it says, if a student who is selected who is male, what is the probability that the student has 15 or more credit hours? So in this case, they tell us that the student is male. So it says, if the student is male. So if you guys recall, when we did conditional probability, the if or the given helped us create our denominator. So if you think about probability as a fraction, we're going to just have total males in the denominator. And if you look at the total males, we definitely have 59 total males, so that's going to be my denominator. And then out of those 59, I look to see how many students have 15 or more credit hours, and there are 21 of them. So in order to do our answer here, we could leave it as a fraction, right? But you want to make sure that you pay attention to how it's asking for the answer. So this one, if we change it to a decimal, we get something like 0.356, or I could put 35.6% for my answer there. And let me make this a little larger so it's not wrapping quite so much. So 21 over 59 would be fine, 0.356 or 35.6. Just pay attention to how they are actually asking for it. Now, again, just to kind of remind you guys, this if is a keyword. A lot of times you'll see the word if or given, and that helps create your denominator. So it says if a student is selected who is male. So that tells me right away that I selected someone who is male. And then out of the males, what is the probability that a student has 15 or more credit hours? So again, we're looking out of that total of 59, and we're looking to see 15 or more credit hours out of the 59. Okay, this particular question is asking us to fill in the table for a credit card where the APR is 17.99% and the minimum amount due is 4%. So we're now getting into kind of the new material here. So in this case, we have to kind of remember how to calculate a finance charge. So if you're not sure, you might want to look back in your notes, but the basic idea is that in order to calculate a finance charge, I'll put like a little formula down here. Finance charge is found by taking the balance, multiplying by the APR, and then dividing by 12. So in our case, we're going to take our $800 balance, we're going to multiply by the APR, and we need to change that to a decimal. So it should be 0.1799, and then we should divide it by 12 because APR is an annual percentage rate. So for this first little spot here, I'm going to get something like $11. Let's see. $11.99. That's what I get there. And then for the new balance, all you have to do is add those two things together. So we just take the 800 plus the 11.99, so I get 811.99. And let me put my dollar sign out front and move this up here. So that'll be my new balance. And then to calculate the minimum payment, basically what I do is I take my new balance, my $811.99, and I multiply by the minimum payment percentage written as a decimal. So this would be 0.04. So I get a value when I do that of $32 and let's see, 48 cents once I round to the nearest. So that should be my value here. And let me go ahead and make this a little bit smaller so we can see a little better. Okay, that fits a little bit better there so we don't have overlapping numbers. So what this tells me is that on my $800 that I put on my credit card or have on my credit card, for month 1, I'm going to owe $11.99 in interest. So unless I pay my entire balance in full, my new balance is going to be $811.99. And then I'm taking my minimum payment and I'm calculating that just by taking the $811.99 and multiplying by the 0.04, since I'd have to pay 4% of my balance, and I get my $32.48. And then to fill in the beginning balance at the beginning of next month, basically what I need to do is I need to take my new balance, which is my $811.99, and I need to subtract the payment that I made, which is the $32.48. So I'm left with $779.51. So that's going to be the last value that I'm going to fill in here, $779.51. Put my dollar sign there, and that would go right there. So that's going to be my last value. And then a lot of times you're asked for more than just 1 month. So you would kind of continue along the same path if you were asked for multiple months. Okay, let's take a look at this one. This says Amy deposits $5,000 into an account earning 2% interest compounded weekly. How much will be in the account after 6 years? So for this one, I have copied the formula from your formula sheet down below. But basically what we need to do is we just need to set this up really carefully, plug it into our calculator. So I'm trying to find balance, or B I'm going to call it. So I take the principal, that's going to be the 5,000, and then I'm going to multiply by 1 plus, my interest rate is 2%, so that's going to be 0.02. Now you have to divide by the number of times that it's compounded each year. So if you look at the keyword here, it says compounded weekly, so that's going to be 52 times a year. And then your exponent is going to be number of times that it's compounded each year, which again is 52 times the number of years, so that's 6. So I had given, I think, most of my classes sort of a hint with this one. In terms of plugging this in your calculator, it can be kind of tricky. I do have it sort of written on the screen here in a way that should work in terms of plugging it in your calculator, but what I often find is that people forget to put the 52 times 6 in their calculator that way, and then what happens is you get the wrong answer. So what I'm going to do is I just want to show you guys kind of one alternate method that you could use. So let me just copy this real quick. Instead of having to remember the parentheses, what you could actually do is you can do 52 times 6 and you'll get a value of 312. And then this is quite a bit easier to plug into your calculator. So either option should work, but if I go ahead and put this in, let's see. I think we get a balance of, and I'll check this in just a second, but let's see, $5,637 and 35 cents, I believe, is what we get there. And I'm just going to plug that in one more time to make sure I didn't screw anything up there. Yep, that looks good. So that's going to be our answer there for our balance in our account. Okay, this one says Rita deposits $5,000 into an account earning 4% interest compounded annually. How long will it take for her money to double? So this should be an easy question, but what you have to do is you have to realize what type of question it is. So this one's asking how long will it take for her money to double? So if you guys remember on your formula sheet, you have this nice little formula here, D equals 70 over P. And what this is telling you is it's telling you doubling time is equal to 70 divided by the percent. So all you actually have to do to find the doubling time is take 70 and divide it by the percent that's given. And in this case, you should leave your percent as a whole number. So you just leave it as 4. So if you take 70 and divide it by 4, you get a value of 17.5. And then your answer is going to always be in years for this formula. So that is going to tell me that in 17 and a half years, Rita will have doubled her money from her original amount. Now, the $5,000 was kind of put there, not really to trick you, but you don't need to use it, okay? It's going to take Rita the same amount of time to take 5,000 and double it to 10,000 as it would take someone to take $5 and double it to $10. The only thing that really matters there is just the interest rate. Now, you could definitely check this question by plugging it into your compound interest formula. And if we do this, if we take the $5,000 and we invest it for a total of 17.5 years, we end up with $9,932. That's just by plugging it into a formula, and I'll go ahead and type it up here in case you want to see it. That would be balance equals principal times 1 plus the rate to the power time. So if I tried it for the 17.5 years, I get 99.3238, which is pretty darn close to $10,000, which would be doubling. So that just kind of verifies that my answer seems okay. Okay, this question is just asking us to explain the difference between PV, PMT, and FV. What do we use them for? So this is more of a discussion question than anything else. But I just kind of wanted to talk about each of these formulas and what they are useful for. So I'll talk about FV first, even though it's at the bottom, because it's the one that is most different from the others. So FV is used for 401k. Because it stands for future value. So if you're interested in figuring out how much money will be in your 401k or some kind of other savings plan, then you would use FV. PMT and PV are both used in different contexts for mortgages or other loans. So PMT is helpful in figuring out a payment if you know the loan amount. So for example, if you know that you're going to be getting a $100,000 mortgage and you want to figure out how much money you will be paying each month, then you can use PMT. PV is helpful if you know how much you can afford each month, but you're not sure how much of a house you can afford. So for example, if you know that your housing budget is $600 each month, you can use PV to help you figure out how much of a house that would actually get you. So with your $600, should you be looking at $75,000 houses or $175,000 houses? It'll basically help you figure out how much of a house can you actually afford. And that one stands for present value. So let's take a look at this one. This says you decide to start contributing $250 to your 401k plan each month. Your employer matches up to 50%. Write an Excel formula that would give you the balance after 25 years if you were earning 2.59% interest. And I have the formula sort of typed at the bottom here from your formula sheet. FV is going to be the formula we would pick because we are talking about 401k and we're talking about future value. So if you look at the first part of the FV formula, we take our interest rate, which is 0.0259. We write it as a decimal, divide it by 12. And then the next thing we put is a comma, and then the number of deposits. So we're going to put in 12 deposits each month over the course of 25 years. So I'm going to have 12 times 25. And then I put one more comma, and then I put a negative sign. And then I need to go ahead and figure out how much is being deposited. So if you think about it, if you're putting $250 in, if you divide that by 2 or multiply by 50%, you figure out that your employer is putting $125 in. So then if you add the $250 to the $125, you end up with a total contribution of $375. So that would be your answer that goes in kind of the last piece. So again, the only time that you have to sort of take that extra step is if you have an employer contribution. You have to figure out what that contribution is going to be and then add it on to your contribution amount. Now, again, there are a couple of other ways you can type this. So I could put 2.59% actually into Excel. That would also work. There are a few sort of correct answers that you can have here. you can actually do the 12 times 25 in your calculator. You'll get a value of 300, and you could put that in the middle spot. That would be fine too. But this is probably the most typical way, or written as a decimal for that percentage. Either way is okay. Okay, here it says a $100,000 mortgage is taken out at 5% interest for 30 years. The monthly payment is calculated in Excel to be $536.82. We want to write the formula that was used to calculate the payment and then determine how much interest is paid over the lifetime of the loan. So this one, we are using equals PMT because I'm trying to figure out a payment amount. And then I'm going to take the monthly interest rate, which is 0.05, or I can type it as 5% divided by 12. And then I'm going to have 12 times 30 because that's my number of total payments. And then the amount of the loan is the negative 100,000. Now this one, see, I'm missing a 0. This one you do not want to put the commas in, because if you put a comma in, it's going to treat it as sort of a separate piece of information that it's given. So this would be what we would type into Excel. Now, in order to figure out the second question, how much interest is paid, if we think about it, we're going to be paying $536.82 every month for 30 years. So if I multiply that value by 12, that's going to give me the amount of money that I spend in a year. And then if I multiply it by 30, that will give me the total amount of money that's spent over the course of the entire loan. So if I take 536.82 and I multiply by 12 and I multiply by 30, I end up with a value of $193,255.20. So that is actually the total amount of money that they spend on that loan. Now, in order to answer the question, it's asking how much interest is paid. So if you guys recall, the total amount that you pay, this oops, I put a decimal where there should be a comma. This $193,255.20, that includes interest and the actual principal amount. And if you think back to this question, we know that the principal amount is going to be $100,000. So if we subtract those two, that is going to give us the amount of interest. So they pay $100,000 towards the principal, and then the other $93,000 actually goes towards the interest. So again, you have to take your payment, multiply by 12 to get the yearly amount, multiply by 30 to get the total amount that's paid, and then you subtract the original mortgage amount in order to get the interest. Okay, so for this question, it says in 2014 there were 21,366 Starbucks stores around the world, which was up from 19,767 in 2013. And we want to find the absolute and relative change. So absolute change, if you guys remember, is new minus old. And then relative change is new minus old divided by old. And I put parentheses around that because when you actually plug it in your calculator, you have to make sure that you remember the parentheses. So for absolute change for this one, I'm just going to take my new number, which is my 21,366, and I'm going to subtract my old number, 19,767. So 21,366 minus 19,767, I get a value of 1,599. And that's going to be stores. So I'm going to put a label on that, and then we'll work on the interpretation in a second. So let's go ahead and do relative change next. So it starts the same way. So I take the 21,366 minus 19,767, and then I divide by my old, my 19,767. And you already did the numerator, so if you have that in your calculator still, you can just leave it there. And then just divide by the old, and you get 0.0809. A nicer way of putting this would be 8.09%. Okay, so that would be your actual answer written as a percentage. And then in terms of an interpretation here, there are a few ways of saying this, but it's nice to include like the year that you're talking about. So I would say something like from 2013 to 2014, the number of Starbucks stores has increased by 1,599 stores, which is a 8.1% increase, something like that, okay? Now using the word increase is always a good idea, or decrease if you have something that's decreasing. Instead of saying like the absolute change is 1,599 stores or the relative change is 8.1%, it's nice to use words like increase or decrease in terms of the interpretation. Okay, this one says surveys that indicate that the percentage of Americans who are unaffiliated with a religious group is increasing. And in 2014, 22.8% of Americans indicated that they were unaffiliated with a religious group. This is up 41.6% relative to 2007. What was the 2007 percentage? So I'm going to go ahead and put kind of our blank proportion. We have amount over base equals percent over 100. That's sort of our general setup that we have. This one's a little tricky because there are two different percents. So what we want to do is we want to use words like increase, decrease, up, down, to help us figure out what should actually go in the percent spot. So in this case, it was a 41.6% increase. It was up 41.6%. So that means I should have 141.6 as my actual percentage. And then the 100 is still on the right-hand side. Now I'll have to figure out how to fill in this left in just a second. But again, this is going to be one of those ones that's easier to see when you actually write it on paper. But you should have the 141.6 because you have that word up. So that indicates that you should be adding to 100. Now, if it were a decrease, you should do 100 minus to get your percent. So if you think about it, for our left-hand side, we're going to have a numerator and a denominator, and one of them is going to be our x. But we have to keep in mind that we know that in 2014 it had increased from 2007. So what that tells me is that my 2014 value, the 22.8, that should actually be with the larger number that goes on the right. So again, this is much easier to see if you have it set up on your paper, written out like with a flat fraction bar. But you can think about labeling the top or the numerator as 2014 because it's up. And then 2007 would be kind of your original that you're comparing it to. So this is going to be your x right here. So you're going to want to go ahead and cross multiply this. And you'll have to divide. And I believe we get an answer that looks something like this. X equals 16.1%. So what this tells me is that in 2007, the percentage was 16.1%, and then it went up by 41.6% and was then at 22.8%. So 16.1 was our previous percentage, our 2007%. Okay, Carrie decides to start saving money for her emergency fund. By the end of 2000, she had saved a total of $1,000, and then by the end of 2010, she had saved a total of $5,000. So we want to write a model for the amount of money that Carrie has saved in her emergency fund, and then use the model to predict how much would be in her emergency fund by the end of 2015. So I have a couple of formulas pasted down at the bottom here. Y equals mx plus b, because that's going to be our linear model. And then I have the formula for slope kind of on the right here. So first thing we actually want to do, this is not one where we can just see the slope. We actually need to calculate it. So we're going to have something like m equals change in y. So you're going to take either one of your y values. It doesn't matter which one. Now, if you guys recall, x is typically time. Anytime you have time in a problem, x is going to be time. So we'll deal with the years in just a minute. For right now, we're talking about our y's, which is actually, it's going to be our dollars. Another way of thinking about that is the amount of money that she's going to be saving is going to depend on the amount of time that she's been investing. So we're going to take the $5,000 minus the $1,000, and then I'm going to divide that by the change in the year, which would be the 2010 and the 2000. So let me move this so you guys can see it. But we should have something like that. And again, I set mine up with lots of parentheses because if I want to plug it in my calculator all at once, then I need all of these sets of parentheses here. And so if we do this, we get a slope of 400. Oops. So let me put my slope right here, 400. That's going to be my slope. What this actually tells me is that she's saving $400 a year, okay? So in terms of writing the actual model, we're going to have something that's in this form y equals mx plus b, since we have a linear model. Let me move this over here. And then all we need to do is we just need to plug in the information that we're given or that we calculated. So y and x are always going to be part of the model. M is the 400 that I just found. And then b is the starting point. And you can actually use either the 1,000. Let me make this a little bigger. Or if you wanted, you could use the 5,000. It doesn't actually matter. Either way is okay. All you have to realize is that if you use the 1,000, then you've created 2,000, the year 2000, to be your starting point. And if you use the $5,000 as the starting point, then you are creating 2010 to be your starting point. Either way is completely okay, but it will change how we actually use the model to predict. So if I set it up to be 1,000 and I want to use my model to predict how much would have been in the emergency fund by the end of 2015, since $1,000 was my starting point, that was the year 2000. So what that tells me is that it has been 15 years since Carrie started saving. So what I'm going to do is I'm going to plug 15 in for my x. So I have something that looks like this. So I take the $400 that she's saving every month, every year, multiply it by the 15 years that she's saving, and then tack it onto her original savings of $1,000, and we get a total of $7,000. So she has $7,000 saved by the end of 2015. So another way that you could have done this, if you use the 5,000 as your starting point, then you would have actually plugged in 5 for your x value because it's only been 5 years. And you would have still gotten 7,000 as your answer, but I just kind of wanted to point that out to show you guys that either way, no matter what you use for your starting point, all you have to realize is that it is important that you understand what your equation is using for your x value. So x, in the case that I have written on the screen, is the number of years since the year 2000. Okay, let's take a look at a different type of linear model. This one says that Suzie is a hoarder and currently has 500 bags of trash to sort through. She intends on throwing away 4 bags of trash each week. Write a linear model that will represent the number of bags of trash that are remaining. Then use the model to predict the number of weeks before all of the trash bags have been disposed of. So in this case, again, I'm going to have something in this form, y equals mx plus b. And this is actually one where we can kind of see what the slope and the y-intercept are going to be just from the information that's given. So she is throwing away trash bags, which tells me that I should have a negative slope. And I'm going to have a negative 4x because she's getting rid of it, so that's why it's negative, and then it's 4 every week. So x is going to be number of weeks, and then she's starting with 500. So that's going to be plus 500s here. So the actual model is going to be what I have here. And then in order to answer the other question, it asks us to use the model to predict the number of weeks before all of the trash bags have been disposed of. So what that tells me is that I want a value of 0 in for y. So I want no trash bags left. So I'm going to have 0 equals negative 4x plus 500. And then I'm going to go ahead and solve this by subtracting 500 from both sides. So if I show a little work here, I'm going to have negative 500 equals negative 4x. Divide both sides by negative 4. So if I take negative 500 and divide it by negative 4, I get a value of 125. So x equals 125 weeks. So that would be my answer there. So about 2 years, basically, would be another way of saying that, or 2.5 years, something like that, because 52 weeks in a year. So again, to kind of think through this logically, if we were just given the setup of the question and asked that question, not about the model, but just about how long it would take for the trash bags to be disposed of, if you think about it, you can kind of check your answer. So we know that she's getting rid of 4 trash bags every week. So if we take the 4 times the 125, we end up with 500. And that matches the number that she started with. So basically what that would tell you is that she got rid of 500 trash bags and she had 500 to start with, which would mean that all of them have been disposed of. Okay, let's take a look at this question here. So a particular insect species is growing in population size at a rate of 18% per year. The current population of the species is estimated to be 500,000. Write a model for the situation, and then we have a couple questions to answer. So let's start with the model. And at the bottom here, since it's giving us a percent, it's telling us the percent increase or decrease. We're going to have something that's exponential. So I'm going to create a formula that looks something like this. I'm going to call amount, I'm just going to call it A. And then if you look at the formula down here, I have initial amount, which is going to be my 500,000. And then I have a parenthesis. And then it's 1, and it's either plus or minus. So if we have something that's increasing, it's going to be plus. And I do have something that's increasing. And then it's 18%. So I would write that as 0.18. And then this is just going to be to the power of time, or t. Make that a little bigger. So that's going to be my formula right there. Another way that I could do this is I could go ahead and combine the 1 plus to just be 1.18, because 1 plus 0.18 is just going to be 1.18. And then I need to use it to answer a couple of questions. So what will the population be after 5 years? So all I need to do to answer that question is just use my original equation, and I just need to plug in 5 for t. And if I do this, if I do my 500,000 times 1.18 to the power of 5, I get a value of, let's see, 1, 4, 3, 8, 7, 9 if I round it. Let me put some commas in here so I can read this a little better. Make that a little wider too. So about 1.14 million, okay, is going to be the number of insects. So, oops, I could put a label if I wanted there of insects. That would be fine. I don't have to, but I could. So that would be the actual number of insects that I would have after 5 years. It has grown by quite a bit because of the fact that that I have such a large growth rate. So 18% is a really high rate, okay? So it's going to increase by quite a lot. Now it asks how long will it take for the population to reach 2 million? So after 5 years, it hasn't quite reached 2 million. So what we actually want to do is we want to do a little bit of guess and check. So what you're going to do is you're going to take your original equation, the 500,000 times 1.18 to the power t, and you're just going to plug in a few values. So for example, I might want to try maybe 7 years. Maybe I think that that's long enough. So if you plug in a value of 7 years, you're not quite to 2 million. So I'm going to try 9 years, and I'm over 2 million. So I'm going to try 8 and see if that works. So 8 is a little bit under 2 million, and 9 is a little bit over. So there are a couple ways that I can kind of structure my answer, but I could say it takes 8 to 9 years for the population to reach 2 million. Now, the actual way of calculating this would be to use something called a log, and that's sort of outside of the scope of this class, so it's not something that you need to worry about. If you want to know how to do it, I would be more than happy to show you that, but that would be something that you would probably want to just come in and ask me during office hours, all right? But giving answers just as sort of a range between 8 and 9 years would be perfectly acceptable for this question. All right, so we really only have one question left. There are 3 questions that go with it, but this is just a scatter plot question. So we are going to use the same equation basically 3 times. So this has Indiana median home value, and it's created this equation. Excel was used to create our least squares regression line, and we're given our y equals mx plus b. We're given the actual values, and then we're given an r squared value, which tells us how well our line actually fits to our data. So the very first question asks us to interpret the meaning of the slope of the trend line. So this one, you want to make sure that you actually use the value that we have here. So the value is 1048.5714. So I'm going to go ahead and round to the nearest whole number of 1049. And I'm talking about dollars, so I'm just going to go ahead and start with that value. There are a lot of ways we could phrase this, but I'm going to say that there's a $1,049, and then since it's increasing, I'm going to put the word increase, and then I'm going to put some context. So there's an increase in Indiana median home value, and then I'm just going to put something like every year, okay, on average. So let me move this so we can actually read all this, all right? But we have something like this, and this is actually sufficient, okay? This basically tells us that every year, on average, home sale prices or home values in Indiana are going to increase by $1,049, all right? So this every year part, that is always going to be part of your interpretation. You're going to have every whatever. So in this case, X stands for years. X could stand for weeks or days, or if we're talking about something different, it doesn't necessarily need to be time. But the basic idea is that it's going to be every 1 unit increase in years, or sorry, in X. So in this case, it's basically just every year. And you want to make sure that you use words like increase or decrease. And then the other thing that you want to do is you want to make sure that you use the actual value of the slope. So this 1,049 that I have, that is the m from my actual equation. You want to make sure that you use that actual value. So just saying that there's an increase in home sale prices over the course of like 1940 to 20 or to 2000, that's good, but it doesn't use the actual value. So you want to make sure that you use the real value in your sentence. All right, this one is same idea, okay, like same setup, but it's asking us to find and interpret the linear correlation coefficient. So you guys do have a formula for this. It's r equals plus or minus the square root of r squared. So in our case, I'm going to have r equals, and mine's going to be positive because we have a positive slope, okay? So all I'm going to do is take square root of the value that's given, 0.94326. So we're going to go ahead and do that in our calculator, take the square root of that, and let's see what we get. Square root is often the second function of your x squared key. So if you're having trouble with it, look for your x squared key, and you're going to take square root. So it's normally you have to do second or shift to get there. So I'm getting something like 0.9712. So that would be the actual value. And again, if we had something that was a negative correlation where you had sort of a line that was decreasing over time, then you would put a negative sign out front. But I would say that this is very close to 1, which shows that we have a positive, strong, linear relationship, all right? So if your value is pretty close to 1, that is going to tell you that you have a strong relationship. And since it is a positive relationship, I'm going to go ahead and put that there. If you had a value that was close to -1, that would show that you have a strong negative linear relationship. And then finally, last question, use the model to estimate the median home price in Indiana in 1980. Was the actual value higher or lower? So all I'm going to do is I'm going to use my equation here, and I'm going to plug in my value of 1980. And I apologize if you can hear my dogs barking. I'm not sure what they're going crazy about, but I'm going to go ahead and take my 1048.5714, multiply by 1980, oops, and then I should have minus, and then I have this 2 million that I have to subtract. 2008142. Let's see. And I get a value of something like this. And then we'll go ahead and make sure that this actually makes sense in just a second here. So I have 68,029 if I round to the nearest whole dollar. So should be something like that. And then if we take a look at 1980 in our chart, I look right up here. This appears, our line, looks like it goes right below the 70,000, and I have a value of 68, which is really close. Okay, so that's my predicted value. And then the actual value, if we take a look at it here, is the actual dot that is right there, and the dot is below. So what above. So what I would say for this one is something like the actual value is higher than the predicted value. And that's because the actual data point is above the line. So I would say something like that for this one. So that's going to be it for our exam review. Good luck studying, and if you have any questions, feel free to email me.